Good afternoon. Good afternoon, Sanskriti. Chala, join first. We are going to simplify remaining theorem, that is the maximum power transfer theorem. Yes, it's evening now. Good evening, Rupesh. Okay. Which one? Which one? Norton's theorem, na, Sanskriti? Suppose I am going to explain another example on Norton's theorem. Suppose here your suppose consider any example. Simplify by Norton's theorem. Find out IL. Find out IL and VL. Okay, resistances were in series. Right? What are the values? Or we can take any values. Suppose V is equal to, suppose 12 volt. Suppose R1 is equal to, suppose 3 ohm. Here also 3 ohm. Suppose this one is 4 ohm and this one is 6 ohm. Find out RL. Find RL and VL. Suppose simplify by Norton's theorem. Simplify by Norton's theorem. Find out RL and VL. So, what is the first step? Listen carefully. Step 1. That short A and B. Terminals A and B. To find IN. So what is the diagram if we short that two? Automatically here R1, R2 and V. The current due to source V is suppose IN. Here, therefore, what is this? What is the resistance of this external loop? R1 plus R2. R1 and R2 are in series. Therefore, overall series resistance is R1 plus R2. So, V is equal to IR, where IN is the Norton's current. In external loop, IN is the current. Due to source V, IN is the current and that flows through this external loop, and to in that external loop, that overall resistance is R1 plus R2 because R1 and R2 are in series. Therefore, IN is equal to V upon R1 plus R2. Now, how do you simplify for IN? V is, what is the value of V? 12 volt. R1 and R2, what are the values of R1 and R2? 3 plus 3, which is equal to 6. Sorry, 3 plus 3, 6. Means 2 ampere. Therefore, in first step, we calculate Norton's equivalent current, which is equal to 2 ampere. Got it, Sanskriti? In first step, we short the terminals A and B. Okay, and consider this external loop. Therefore, current flows through this external loop due to that source V, and that current is R. Now that current I is divided through this, and again total current is IN here. Okay. There were 3 resistors. Where Sanskriti? Yes, 1, 2, 3, 4. RL, that is the RL. Okay. What is the next step? Step 2. Now step 2. What we have to do? We have to disconnect RL. In second step, we have to short circuit that source and disconnect RL to find out the equivalent resistance. Short circuit source V and remove load resistance RL to find equivalent resistance RN. It is a similar step like your Thevenin's theorem. There we find out RTH, here we find out RN. Okay, equivalent resistance. So our circuit diagram is like this. Here your R1, here your R2, here your R3. We remove RL, here your point A and here your point B. Here R1, R2 and here your R3. We remove load resistance RL and also remove the battery. Therefore our circuit is like this. So we have to find out the equivalent resistance between terminals A and B. We have to find out equivalent resistance between terminals A and B. Okay, so consider that R1 and R2 are in series. Therefore, the circuit diagram becomes like this. Here R1 series with R2. This resistance is R1 series with R2. Therefore, 3 plus 3, 6 ohm. And here your resistance 4 ohm. Do you understand? If we consider the common series resistance in place of this R1 and R2, that series resistance is R1 series R2 is 6 ohm. 3 plus 3, 6 ohm. And here R3 4 ohm as it is. So this series 6 ohm and 4 ohm, these two resistances are in parallel because 6 ohm resistance, this end also connected to each other, this end also connected to each other. Therefore, they are like this. Okay. So, here 6 ohm resistance and 4 ohm resistance are in parallel. Therefore, Rn is equal to Therefore, this into this upon this plus this. Okay, so what are the values? 6 multiplied by 4 upon 6 plus 4. Therefore, 24 upon 10. Therefore, Norton's equivalent resistance is 2.4 ohm. Norton's equivalent resistance is 2.4 ohm. Do you understand? Now, do you have any question? In first step, we short circuit terminals A and B to find out Norton's equivalent current due to the source V. Okay? By just considering that external loop, we carefully observe that in external loop there is, yes, in external loop there are only two resistances R1 and R2, therefore external resistance is 6, and according to that our V is 12 volt, therefore IN is equal to 2 ampere. In second step, we remove that source V and also remove load resistance RL to find out the equivalent resistance RN. So our diagram becomes like this when we remove the source and when we remove the load resistance. Our circuit diagram, by combining these two in series, the value is R1 series R2 is 6 ohm because this one is 3 ohm, this one is 3 ohm, 3 plus 3 is 6, and here R3 4 ohm as it is. So these two are in parallel. हे parallel याच्या अक्रॉस ही जर इथली वायर मी मोठी केली तर इथे रेजिस्टन्स येईल. Means carefully we observe that these two resistances are in parallel. Therefore, Norton's equivalent resistance is 2.4 ohm. What is the next step? In next step, we draw Norton's equivalent circuit. Okay? Write down all these steps, please. Okay. Draw Norton's equivalent circuit. That is, here your source RN and here that resistance RN is in parallel because that one is a current source. Whenever there is a voltage source, that resistance is in series, but for current source that resistance is in parallel. Okay. Now this one is a Norton's equivalent circuit where RN we get 2 ampere and here 2.4 ohm. Now we connect load resistance. Now we connect load resistance RL and to find VL and IL. Now how you find out IL? IL is equal to RN this upon this plus this multiplied by I. RN upon RN plus RL multiplied by RN. Okay. So what is the value of RN? 2.4 upon 2.4 plus 6 multiplied by 2. अशी फिगर आलं बघा. Therefore 0. RL is equal to 0.21 5 are 125 ना. Means 49. I think 49. 0.56 ampere. Okay. Do you get answer? Yes, yes. Next digit is greater than 5, therefore 0.57 is the right answer and VL is equal to 3. Okay, Karthik, right, right. Okay. So write down all these steps. 3.42 volt. Okay. Do you understand? All of you? Now all of you are prepared with that Thevenin's theorem and Norton's theorem. The last theorem we are going to study, that one is the maximum power transfer theorem of this chapter. And there are no numericals on that. We have to study the statement only. So write down. Before that, do you have any difficulty? Now do you understand, all of you? Any question? Okay? Okay. Okay. Write down the heading as maximum power transfer theorem. Okay? I am going to draw that diagram. Similar diagram you have to draw. You know that V is equal to I into R. That is the general statement of Ohm's law. But whenever we think about or we speak about the EMF of the cell, that battery having some internal resistance, and that is shown in this diagram, that source having internal resistance small r, at that time EMF is given by V is equal to IR plus I into R. Okay, that is E is equal to overall current is I and overall resistance is external resistance plus internal resistance. At that time we say that battery having AMF E. So here that one is a variable resistance. That arrow shows we able to vary the load resistance RL. What is variable resistance, that we are going to study in 11th, that chapter number 4 of paper 1, study of components. In that chapter we are going to study about different type of resistances, capacitances, inductances, then transformer. So many things we are going to study in that chapter. आपण करणार आहोत हा सगळा अभ्यास. We will going to study. ओके. आता व्हेरिएबल रेजिस्टन्स म्हणजे त्याच जागेवर त्या 2 पॉइंट मधला रेजिस्टन्स कमी किंवा जास्त करता येणं याला आपण म्हणतो व्हेरिएबल रेजिस्टन्स. सो हियर whenever that external, by varying this, when we adjust that RL exactly equal to internal resistance, then maximum power is transferred from source to load. Power P is equal to what? I square R. Okay. So when that RL load resistance is exactly equal to internal resistance, maximum power transferred to load. Okay. So that is the statement of maximum power transfer theorem. Okay. Maximum power transfer theorem states that whenever in circuit that load resistance is equal to the internal resistance of the source, then maximum power is transferred to the load. Okay. And as I told you, suppose 10 volt battery across RL we get near about, out of that 10 volt we get near about out of that 10 volt we get 9 point something, somewhat potential drop across that load resistance. But whenever these both resistances are of equal value, we get maximum power at the output. Outputला जास्तीत जास्त power transfer होईल. That is known as a maximum power transfer theorem. What happened? Is there any problem in video? Is there any problem in internet connection? Okay. Okay. So, here what is the statement of maximum power transfer theorem? Whenever that in any circuit whenever load resistance is equal to the internal resistance of the battery or internal resistance of the cell, maximum power is transferred from source to load. Maximum power is transferred from source to load. Everyone understand this? Now suppose state and explain maximum power transfer theorem, then we have to state in words that statement and write down these steps. Okay, so write draw this diagram and these steps and write down this one bold work. Okay. रुपेश परत नेटवर्क जातंय का? No. I think it is clear. Is it clear now? Or buffering? Okay, okay. Background sound. Okay, window लावते एक मिनिट. Write down maximum power transfer theorem states that, write down. You do not have a book? Maximum power transfer theorem states that the power transferred from source to load is maximum. Power transferred from source to load is maximum when load resistance is equal to the internal resistance of the source. When load resistance is equal to internal resistance of the source. Okay? Only 2 students are attending live session. Okay, last one numerical of Kirchhoff's law is remaining. That we try to simplify. That one is actually solved numerical in your textbook. But I am going to explain that one, and then near about one small 5 to 10 minutes point is remaining. हो बरोबर आहे. आपलं एक लेक्चर काही ना काही करून कॅन्सल होत होतं ड्यू टू पर्सनल रिझन ऑर इंटरनल इश्यू सॉरी इंटरनेट कनेक्शन ऑर सम वॉट. हां 12चे सकाळीच असतात ते बरोबर व्हायचे. आपले ओनली 2 lectures, 1 we missing. That's why I try to take it today only. We complete that one numerical and then we continue in our next lecture. So I am going to draw that a diagram. See in your textbook, if you are having textbook, then see page number 22. Page number 22. Page number 22, R1, R2, R3, R4, RL. 15-volt battery. Draw this diagram simultaneously with me. You have to draw one bridge. So first we write down given data that V is equal to 15 volt. And what are the values of R1, R2, R3? 3, 2, 2, 3. Okay. RL is what? 1 ohm. And solved by Thevenin's theorem, find VL and RL by Thevenin's theorem. Solved by Thevenin's theorem. Okay. So what is the first step of Thevenin's theorem? Remove load resistance RL to find out VTH. Okay. Remove RL to find VTH. So what is our circuit diagram? Here I draw the diagram like this. We remove load resistance RL. Now if the bridge is like this, we may write this wire we extend and keep like this. R1 and R3 अशा ऐवजी आपण असे केले तरी चालणार. हा पण पॉइंट स्टिप केला आणि इकडनं R4 and R2 as it is similar diagram only. There is no load resistance. Do you understand this diagram? Okay. Now we have to, according to Thevenin's theorem or according to Kirchhoff's voltage law, we have to give the polarities. Minus sign is here, that's why this resistance is minus. Here point, this one is plus. Here this end is negative, this end is positive. Here also this end is negative, this end is positive. Here also this end is negative, positive. Because this one is one closed loop and this one is another closed loop. ओके. हे एक क्लोज लूप झालं, त्याच्यातनं करंट फ्लो होईल आणि दुसरं एक क्लोज लूप असं होईल. ओके. आता त्याच्या पोलॅरिटीज आपण कशा मार्क केल्या? निगेटिव्ह इकडे म्हणून, इकडे निगेटिव्ह, इकडे पॉझिटिव्ह, इकडे पण निगेटिव्ह पॉझिटिव्ह अप टू पॉझिटिव्ह. हियर ऑल्सो निगेटिव्ह पॉझिटिव्ह निगेटिव्ह पॉझिटिव्ह पॉझिटिव्ह. ओके. So we have to find out VTH. For that we have to find out the potential drop across each resistance. VR1 is equal to what? I into R1. R1 ची व्हॅल्यू काय आहे? 3. ओके. Voltage source is given, na? According to potential division, we have to simplify. Now, here, this one is one series combination, this one is another series combination. To find out the potential drop across R1, we have to write R1 upon R1 plus R2 into V. So, we have to write R1 upon R1 plus R2 into V. Therefore, what is the value of VR1? Do you understand, all of you? Okay. What I have to show? Wait. How to show? suppose like this. Here these cliffs are your R1 and R3, like this. इकडे हा पॉइंट सोडून मी हे फक्त असं करू शकते की नाही? इज देअर एनी चेंज? त्याच्या व्हॅल्यू मध्ये काही चेंज? R1 ॲज इट इज अँड R3 ऑल्सो ॲज इट इज. फक्त अशा ट्रँग्युलर पोर्शन आहे, म्हणजे देर आर फ्लेक्झिबल वायर्स, सो वी कीप दॅट वायर ॲज इट इज ॲज लाईक दिस ऑल्सो. अशा ऐवजी हा ट्रँगल पोर्शन ऐवजी ओके मी असं जरी केलं तरी पण R1 आणि R3च्या व्हॅल्यू मध्ये किंवा त्याच्या अक्रॉसच्या पोटेन्शियल ड्रॉप मध्ये काही फरक पडणार आहे का? नाही. डू यू अंडरस्टँड? सो दॅट ब्रिज अशा ऐवजी मी असा केला, असा होता ब्रिज, त्याच्याऐवजी असा केला आणि रेजिस्टन्सेस असे केले फक्त. आणि RL हा काढून टाकला आहे, हे पॉइंट्स असे केले. म्हणजे तो ब्रिज वरनं पण असा केला, साईडने पण असा केला, तर त्याचा रेक्टँगल तयार होईल की नाही? रेक्टँगल तयार होईल की नाही? हा असा असा मध्ये दाबला तर स्ट्रेट लाईन होईल. ओके, हाही असा दाबला तर एक स्ट्रेट लाईन होईल. आणि मग नंतर साईडचे टोकं पण दाबले तर अशा वर्टिकल स्ट्रेट लाईन्स होतील इथे अशा. आणि हिअर युअर R1 at its place, R2 at its place, R3 as it is and R4 also as it is only. Okay, Rupesh, do you understand Rupesh now? Please tell. येस, साईडने प्रेस केला, हे बघा. ओके, व्हेरी गुड. म्हणजे आधी मी वरचे टोकं प्रेस केले तर असं होईल ते सर्किट. फक्त वरचे टोकं प्रेस केले तर असं होईल. ओके, इथे इथे असं स्ट्रेट लाईन होईल. मग नंतर मी असं केल्यावर ही पण लाईन स्ट्रेट होऊन जाईल, म्हणजे मग तो रेक्टँगल फॉर्म होईल. फ्लेक्झिबल वायर आहेत, त्या कशा पण फ्लेक्झिबल होऊ शकतात. तुम्ही तुमच्या इलेक्ट्रिकल वायरिंग बघता, इलेक्ट्रिकल वायरिंग व्हर्टिकल लावली काय किंवा अशी लावली काय, कसं पण अशी अशी केली तरी पण, असं असं केलं तरी पण तेवढाच प्रकाश मिळतो आपल्याला, तेवढीच इंटेन्सिटी राहते लाईटची. म्हणजे त्याची पोटेन्शियल किंवा रेजिस्टन्स व्हॅल्यू मध्ये फरक पडतो का? नाही. ज्यावेळी त्याची पोझिशन आपण चेंज करतो, कोणत्या दोन याच्या अक्रॉस ते कनेक्ट केलेलं आहे, ॲट दॅट टाइम देअर इज अ चेंज इन ओव्हरऑल व्हॅल्यू. कोणत्या दोन पॉईंटच्या अक्रॉस रेजिस्टन्स कन्सिडर करतो, दॅट डिपेंड अपॉन दॅट. सो हिअर मग आता हे 2 मिनिटात बाजूला ठेवा. हा आता इथनं येणारा करंट इथं येऊन ह्या पाथ मधनं असा जाणार आहे. सपोज I इज द करंट, I1 इकडनं जाणार आहे, I2 इकडनं जाणार आहे. I1 इज द करंट थ्रू R1 and R2. So what is the potential drop across VR1? I1 R1. तो कसा काढणार आपण? According to our potential division, these two are in series. Therefore potential drop across R1 is R1 upon R1 plus R2 into V. So insert the values and get the value of VR1. R1 is what? 3. 3 upon 3 plus 2. 3 plus 2 multiply by 15. 9 volt. So VR1 is equal to 9 volt. Similarly, we calculate VR2. VR2 we calculate R2 upon R1 plus R2 multiply by V. What is the value of VR2? VR2 is equal to R2 is 2 upon 2 plus 3 multiply by 15. 30 upon 5 is equal to 6 volt. VR2 is equal to 6 volt. Okay, but as due to these polarities, means here potential drop is 9 volt, here potential drop is 6 volt. Here also R3 ची व्हॅल्यू सिमिलर आहे की नाही 2, म्हणून याचा पोटेन्शियल ड्रॉप पण काय येणार 6, याचा पोटेन्शियल ड्रॉप काय येणार 9. ओके, म्हणजेच 6 minus 9 minus 3 volt पोटेन्शियल डिफरन्स येणार. VTH काय येणार? आता A आणि B हे 2 पॉइंट असते तर काढणं सोपं होतं, 6 plus 9 केला असता VTH. पण ह्या 2 पॉइंटच्या अक्रॉस पोटेन्शियल ड्रॉप काढायचा आहे तुमचा. थेवेनिन equivalent potential is between point A and B. That's why we have to divide these two potential. But this point is negative. means we are 4. We have to consider -9 old. घाबरू नका, कन्फ्यूज नका हो. इकडे म्हणूनच मी पोलॅरिटीज कशा मार्क केलाय, निगेटिव्हने स्टार्ट होतो आहे म्हणून हा A टर्मिनल इज निगेटिव्ह विथ रिस्पेक्ट टू ग्राउंड. Okay, that's why R4 we have to consider -9 and VR3 is equal to -6. याला पण -6 घ्यावं लागेल. Okay, so what is the potential difference? -6 -9. हा सॉल्ड न्यूमेरिकल आहे तुमच्या टेक्स्टबुक मध्ये. परत एकदा रीड करून घ्याल. Okay, therefore VAB is equal to VTH is equal to VR4 minus VR3 is equal to -9 minus -6 which is equal to -9 plus 6 which is equal to -3. So VTH is -3 volt. ऑफकोर्स आता ह्या 2 पॉइंट मधलं काढायचंय आणि ह्या पोलॅरिटीज अपोजिट आहे म्हणून तो पोटेन्शियल डिफरन्स काय आला, मायनस आला. ओके, येस 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 येस. इथे पण हा काय येणार, -9 मायनस 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 प्लस 6. -9 प्लस 6 परत आन्सर काय येणार, -3. या दोघांच्या अक्रॉसचा पोटेन्शियल these two are in series, but that's this series combination and this series combination is in parallel and across parallel potential drop remains constant. म्हणजे इथे जो असेल तोच potential drop या दोघांच्या मध्येही असेल म्हणून हा VAB काय येणार, -3. ओके, constant. Yes. Now what is the second step? काही काळजी नका करू, एक्झामला मी हे टाकणार नाही, पण ह्या प्रकारचं थोडंसं सगळं स्ट्रेट फॉरवर्ड नसणार आहे ना. सोपं सोपं सगळं शिकायचं का फक्त. ओके, थोडंसं डोक्याला त्रास होईल असं पण काही शिकायला पाहिजे की नाही. सो व्हॉट इज द राईट एक्सप्लेनेशन, गो थ्रू वन्स इन युअर टेक्स्टबुक ऑल्सो दॅट यू हॅव टू. हे मार्किंग मी कसं केलं हे समजलं का. किर्चॉफ व्होल्टेज लॉ मध्ये शिकलो होतो, मायनस एंडने सुरू करायचं. ह्या पाथ मध्ये मायनस प्लस हिअर प्लस एंड लाईक दिस. सो हिअर व्हेन वी कन्सिडर VTH इज VAB, पोटेन्शियल ड्रॉप अक्रॉस AB. सो one minute. Please join. Is it clear now? Okay. Shall we continue or quit? खूप कमी स्टुडंट्स आहेत. नेक्स्ट लेक्चरला घेऊयात का हे न्यूमेरिकल. तोपर्यंत ट्राय टू अंडरस्टँड फ्रॉम युअर टेक्स्टबुक. ओके, देन वी विल कंटिन्यू इन अवर नेक्स्ट लेक्चर. ओके.